Okay, so this is graphing. I think it is part 3. So you were supposed to graph this equation, and I would have chosen 0, 4, and 8 as my x values since my x was being multiplied by 1/4. You didn't have to, but that's what I chose. And I graphed those points, and I took a straight edge this time, and I graphed a line through them. So just picking 3 points will allow me to see all the points on that line because I drew a line through them. If you have any questions, you can always email me or text me. Okay, so what if the equation doesn't look like the others? In other words, what if it's not y equals? So all the ones the 2 that we did so far was y equals, and then you could just do the math and get the y value. If y is by itself, it's easy because you just plug in the x values. The best thing to do if y is not by itself is to rearrange the equation so that it does look like the others. So in other words, we want to rearrange the equation to get y by itself. And to do that, we're going to follow the rules of algebra, just like we solved equations in Chapter 2. We can add, subtract, multiply, and divide as long as we do the same thing to both sides. So it's just like solving an equation. We're going to do the opposite until we get y by itself. So you might see an equation that looks like this. That is actually called standard form. And we're going to rearrange it so that it looks like this, where y is by itself. Okay? I think a couple slides back we had one in standard form like this, and we plugged in the x value, and we had to kind of like solve it to find the y value. So if we solve it first, then we don't need to do that every single time. Okay, here's how we would do that. So number 1, we're going to drop the line just like we did when we were solving an equation. And then the goal is to get y by itself. So if the x term is on the same side, then I want to add the opposite. So I want to get this by itself, so I'm going to add the opposite of positive 3x to both sides. Now here's the thing. Those cancel. 3x minus 3x is nothing. I have 2y left. The problem is the 10 and the minus 3x, they're not like terms. So I can't really add them together. So I'm just going to write negative 3x plus 10. If you have 10 minus 3x, it's the same thing, but we want to try to make the x part come first. So since it was a minus 3x, I kept the 3x as negative. Now the y isn't totally by itself, so I need to divide by 2, just like I would in an equation. The thing is, I need to divide everything by 2. So 2 divided by 2 is 1. That gives me 1y. Now here, negative 3 divided by 2, leave it negative 3 halves. Plus 10 divided by 2, since that turns out to be 5, I'm going to leave that as 5. And there is my equation, just rearranged so that it is in y equals form. Okay? Couple examples. So let me do these for you really quick. Drop my line. Wherever my y is, I want to add or subtract the x term to get it away from the side. So since it's minus x, I'm going to add x. I don't know why there's a 10 again, but these x's cancel, so I'm left with 3y. They are not like terms. I cannot just combine them together. So I'm going to put the x part first, plus 10. Okay, so again, notice it's not 10x, it's x plus 10. I need to divide everything by 3. And basically I'm going to leave it like that. So I'm going to have y equals x over 3, which is really the same as 1/3 x, plus 10/3. You can leave it as 10/3, or if you want to make it a mixed number, you can gladly do that. So that's how I would rearrange that equation. Next, here's my y value. The 2x is positive, so I'm going to subtract 2x. Okay? Be careful. Some people forget about this minus sign. That makes my y negative. My negative 2x I'm going to put first. My 4 is positive, so it's plus 4. And when I have a negative y, it's kind of like a negative 1. So basically I'm going to divide everything by negative 1. So I end up with positive y equals positive 2x minus 4. Since 4 divided by negative 1 is negative 4, I'm just going to write minus 4. And then there's that equation. So these two, the green and this, they're the same thing. They're just in a different form. These two, they're the same thing. They're just in a different form. It's like having a dollar bill or having 4 quarters. It looks different, feels different, but it's the same exact thing. Okay, so you may need to rearrange an equation to get it y by itself. All right, so moving on, special graphs. If there's no x value, that pretty much just means that x doesn't matter. So if there is no x value, you're going to have a horizontal line. That is something you need to remember. If you don't remember it, make sure it's in your notes and make sure you look at your notes, okay? So no x value, horizontal line. Here's an example. If y equals negative 5, what that means is I'm going to go down to negative 5, and everywhere where y is equal to negative 5, that's my line. So these are not just points, they're lines, okay? It doesn't matter what x is, the y value is always negative 5. I should have made that one red, huh? So that is y equals negative 5. And then the same is true the opposite. If there's no y value, then it's going to be a vertical line. So for example, if x equals 0, I go to where x equals 0, which is right here. Everywhere on this vertical line, the x value is always, always 0. Okay? So this is the line x equals 0. This is the line y equals negative 5. It is definitely tricky because people think, oh, well, where x equals 0 should go horizontally because the x-axis is horizontal. No. Okay? It means everywhere x is 0 is going to be my line. So again, make sure it's in your notes. Use your notes when you have to do these kinds of problems. The last one that I have on here, I'll use green. There is only a y in it, but y is not by itself, so I'm going to subtract 3. And then my equation is y equals negative 3. So I go to where y is negative 3, which is right here, and that line is everywhere that y equals negative 3. So those are the special cases. Be careful when you see them. I am going to stop here, and I'm going to make it one more video, so there will be a part 4. So